All right, here we go again. Let's do our second example for application. And here we are dealing with uniform motion. So it says a riverboat traveling upstream against the current on the Mississippi River takes 3 hours to travel 24 miles. The return trip downstream with the current, now again with the current, it's going with the current this time, only takes 2 hours. Find the speed of the boat in still water and the speed of the current. All right, so now again this is going to be one of those tables that we want to set up, and we got to make sure that we understand the setup of the problem here. So now the way you would set this up is using distance equals rate times time. Okay, so if you set up your table, so you've got let's do it this way. Okay, so here you've got distance, rate, and time. Now distance is in miles, and then the rate is going to be miles per hour, and of course then time is in hours. And we'll have two different equations based on when they go upstream and downstream. So upstream and downstream. Now, when they're going upstream, the distance going back and forth is still the same, right? So it's 24 miles both ways, right? So that doesn't change. Now, the rate, oh, by the way, let's use B is the rate, the speed of the boat in still water. And C is the speed of the current. Okay. Now, if you're going upstream, it's going to be the speed of the boat minus the speed of the current because it's going against you. So it's going to be B minus C. When you're going downstream, it's going to be with you, so it's adding to your speed, so it's going to be B plus C. Okay. And then the time, it took 3 hours to get there going upstream, but only took 2 hours going downstream. And here's the thing. We want to find what? The speed of the boat and the speed of the current. Okay? So, how do we do this? Well, again, like I said before, we're going to use the distance equals rate times time and the relationship between the two. Okay? So, we're going to set up two equations based on that. So, it's going to be distance 1, or excuse me, let's do distance U. For distance upstream equals what? The rate going upstream times time, and then distance downstream equals the rate going downstream times time. And so this here is just going to be what? It's going to be B minus C times T. And this one here is going to be B plus C times T. Right? And the thing is the distance for both of them is the same, which is 24 miles. Okay? So let's plug in the values here. Watch what happens. So this is going to be 24 This is going to be 24. This is going to be 3. And this is going to be 2, right? And so now, when we simplify stuff, we got 24 equals 3b minus 3c, and 24 equals 2b plus 2c. Okay, so now we've got two equations with two unknowns. And all we have to do is solve for them. Now, at this point here, look for ways of simplifying things. So 24 is divisible by 3 and 24 is divisible by 2. So if I divide through by 3, this becomes 8. And this becomes 1 and 1. And if I divide by 2, this becomes 12. And this becomes 1 and 1. And look at that. If I just add these two equations, the c's are going to drop out. And I get what? I get, and sometimes it works out that nicely. Not always, but sometimes, so always look for it. So this is going to be 20 equals 2b. And so now I'm going to divide by 2, and I get b, the speed of the boat, is 10 miles per hour. All right, cool. Now, guess what? Now I just have to plug into one of the two equations, right? So now I'm going to take this one. 12 equals b plus c. So c is going to equal 12 minus b. So c is going to be 12 minus 10, which equals 2 miles per hour. So the speed of the current is 2 miles per hour, and the speed of the boat is 10 miles per hour. And we're done.